right. Hello, everyone. Welcome to 27th of May, CSE 102. So a couple things today. What we're gonna talk about is we're gonna introduce sets and maps. So this will be pretty exciting because, at least for me, but it'll be pretty exciting because what we're gonna introduce today would be actually really quite useful in this last assignment that you guys are working on. And you'll see why as we get into it. So here's how the structure of today is going to go. One is first I want to have a little bit of a brief discussion based on some questions that people are giving me and sending me about the assignment. And then we're going to talk about sets and maps, and then we'll have our break, and hopefully we'll get through all the slides before the break. But once we're done with the slides, then we'll do examples. And I'll also, like I said last week, I told you guys I was going to pull up the my tablet and do some drawing, some whiteboard type stuff to show you kind of how these data structures are. So that, again, this isn't a data structures class. This isn't an algorithms class, but I would like to at least get you some knowledge about how this stuff works, because it's not all data structures are created equal. There's a reason why we have multiple different types of data structures, and not all languages, not all programming languages are all the same. There's a reason we have different programming languages and why different people like different programming languages. It's not that any of them are inherently better or worse than any other. It's just that some of them are really good for doing certain things. And so what I'm going to do is let's go ahead and get kind of straight into the slides so that we can do that. If it can come up. Let's see. Oh, that's how, hold on. Wait a second. I think I may have just figured out something I've been trying to figure out about this new team setup. Okay. Sorry. Okay, so I just figured out something cool about the team setup. That's yep, that's it. Okay. All right. So first things first about the assignment. So this quote, I used it actually last semester in CSE 101. It's one of my favorite. It's one of my favorite quotes. This guy Edgar Dijkstra. He's kind of older. Well, he is there's a graph algorithm, a tree search algorithm that's got his name on it. So he's kind of a well-known figure in our field. So, but what he says here is the computer science is no more about computers than astronomy is about telescopes. And what we mean by that is the computer is the tool. It's not necessarily the thing we are creating, right? In the sense that what I'm teaching you is how to analyze problems and be able to generate solutions, right? And use the tools that we have. We have computers as tools. In this class, we are specifically using Java as a tool. And so in the same way that astronomy is about the study of stars, the telescope is just the tool that they use to be able to study those stars. And in the same way, computer science is not, we're not studying computers. We're using computers to learn how to solve problems. And the reason why I wanted to bring this up is because I've got a number of questions regarding this fourth assignment that is, I used an array list. Is that okay? Is that right? Is that something I can do? What's the right data structure I'm supposed to use? What's the right thing I'm supposed to do with this? And yes, I mean, array lists are fine, right? Array lists are something you've learned and you can use them, and that's great. You could also use arrays, right? That may require a little bit more work. You could also use linked lists, right? Again, also that may require some work. What we're going to introduce today with sets and maps, you could use that. You could use one of those. There's all kinds of ways that you can solve the problem. And in fact, that's the reason why, like, for in the assignment, I don't put a method in there that says return an array list of courses the student has taken, right? And the reason why I didn't put a method like that in there was because I didn't want you to feel forced to have to use array lists. I wanted you to be able to use any data structure that you thought was okay. Right? So part of being a computer scientist, part of being a computer engineer is being able to look at the problem, be able to say what tool is going to work well for this problem, and be able to use that tool and know that someone else may look at the problem and decide that a different tool will solve the problem for them, and that's okay, right? You shouldn't be looking for a one right answer type of thing. But know that some tools are better than others. And the example I often give as far as what tool will do the job, right? The example I often give is, imagine I'm sitting in our salon at our home and my wife comes out of the kitchen or comes out of the other room or wherever she happens to be and she says, there's a spider. There's a spider in the kitchen. Can you go kill it? Okay, which my wife is much braver than I am, so this actually would never happen. She would just take care of it herself. But anyway, if I go in there with a shotgun, will a shotgun kill a spider? I give you a second to think about it. Will a shotgun kill a spider? And hopefully you are thinking to yourself, yes, Arjun, thank you. Yes, a shotgun will kill a spider. Is a shotgun the best tool to kill a spider? Hopefully you guys know that it's not the best tool to kill a spider in a kitchen. Same thing with a flamethrower. A flamethrower will kill a spider, but I'm not about to go use a flamethrower in our kitchen, right? Now what I might get is I might get a slipper. I don't have one handy, but a slipper or a shoe or a newspaper, if I have a rolled up newspaper, right? That would be a good tool to kill a spider, right? Or I have some friends that they don't like killing anything, and so they might get like a glass. Again, I don't have one of those either, but a glass and a plate, and take the glass and like try to like scoop the spider up and go bring it outside. Yeah, all of those things are good tools, right? But just because the flamethrower and shotgun will get the job done, it doesn't mean it's the best tool for the job. Okay, but as you can see, slipper, tennis shoe, newspaper, glass and plate, like all of those are perfectly fine. So if you were to say which one answer is right, there isn't one. There isn't a one right answer for how to get rid of a spider in your home, right? And so in the same way, array lists, great. Arrays, great. Lists, great. Linked list, great. Hash set, great. We're going to get this into hash map here, great. You know, all of those are good solutions, tools to use to solve the problem that's contained in assignment 4. So, all right. Yeah, you can say one of them is best, but even that is going to be dependent, Arjun. So if you think about it, like even those last two examples where what I might do, okay, and if anybody's a spider lover, can't stand the thought of killing a spider, just close your ears. But my solution would be a slipper or a rolled up newspaper would be, well, we don't really have paper in our home. We're all digital and everything now, right? But I would take a slipper and go, right, and kill it. Someone else might say that's not the best solution because then the spider dies. Someone else might really say the spider deserves to live just as much as you or I, so their best solution would be in some way to make sure the spider still lives, So anyway, the reason why the glass and plate wouldn't work for me is because I've had too many times where I've tried to do that out of trying to not let the bug get killed, and I've end up not fast enough, I'm not quick enough, and so the bug ends up getting away instead, which is really not a good solution for our family. So all right, so that's kind of my monologue, my kind of lecturing about how to consider the analysis of a problem and developing a good And whatever you determine is best solution. So again, Arjun, yes, you can say one of them is best, but be prepared. Someone else may say that they have a solution that is better for them, okay, based on their analysis. Okay, all right. So let's get into the meat of stuff here. Let's get into actually hash sets and hash maps and all that fun stuff. All right, so if we think of that, what we've talked about so far, the collections that we've talked about so far, arrays, array lists, well, array is not really a collection, but you get the idea. But array lists, lists, queues, stacks, right? These things are all ordered collections, right? So what is stored in position 0 in index 0 will always be there, and it matters that it's there, right? It matters that it's in position 0. And then the next thing, well, I guess you're left to right, so position 0. And then whatever's in position 1 is in position 1, and unless we move it, it's going to stay there. And it matters that it's there, and position 2 and 3 and so forth. And what I mean when I say it matters that it's there is that, so take what's it called? A linked list, for example. A linked list, in order to get to index 3, right? We have to go from 0 to 1 to 2 to get to 3. Okay. In the same way with an array list, we don't have to jump over those things, but we have to know where an item is in order to get to it, right? So if I want to get the thing in index 3, I have to access index 3. Like I have to actually go to that position in the array list to get to it. That's a ordering. It matters. Now that's not the same as sorted. Okay. Ordered simply means the thing in position 0 will stay there. The thing in position 1 will stay there. The thing in position 2 will stay there unless we move it. So when we add a new item to the end of an array list, it always just gets put on the end. It always gets, so if there's index 3 so far, and we want to put a new item, we want to add a new item to the array list, it's going to get put in position 4, right? There's no other place for it to go, right? Unless we use an extra index value to say we want to insert it into a certain position, right? But even then, in order to do that, all the other items have to move, right? So that's what ordered means. It means that the index position matters, okay? Also, in an array list and an array, we can have duplicate elements. We can have the same thing more than once. So for example, if I wanted to store an array list of courses that a student has taken, and I wanted to, some of you did this for assignment 2, I believe. Some of you did this, which is perfectly fine. A great solution for assignment 2, right? You stored multiple array lists where you had an array list of courses, you had an array list of grades. Okay, and the position 0 course went to position 0 grade, and position 1 course went with position 1 grade. Okay, great way to do that, right? But what if the student took the same course more than once, right? And we want to do that for assignment. What is that for assignment 4, right? Yeah. So we would have to be able to have the same course twice in our array list, right? Or what if they got the same grade twice? What if they got 100 in 2 different courses, right? Then our array list of our grade values would have to be able to have duplicates, right? Okay. So what about if we want to be able to have a collection that is not ordered and we don't allow duplicate elements? Well, in math, we call that, well, in math and in other things called set theory, we call that a set, right? A set is simply saying if something's in the set or not in the set, right? And in a set in math, you know, we usually draw like Venn diagrams and fun stuff like that. And I could talk forever on this because I love set stuff in math, right? we can have a set of items, and we just simply ask, is it in the set or not in the set? Right? Now, the thing about sets is we don't allow duplicates, and the order doesn't matter. Right? And so it's an unordered, non-duplicate collection. There's 3 different types of sets that this slide talks about: hash set, linked hash set, and tree set. Okay, we will go through the compare performances of these things. Okay, and then we're going to also talk about a map. Now, imagine a map. In a lot of ways, it's kind of like it's like an array or an array list, but instead of indexing by an integer value, so instead of saying 0, 1, 2, 3, 4, and so forth, what if instead we had a special key value that would say this index is going to, this key is going to tell us, and that key could be an object, right? That key could be anything. It doesn't have to be a primitive type. In fact, it can't be a primitive type. Right? But let's say that we wanted to use something like, oh, I don't know, a person's name or a person's phone number as a key value, and then we could use that key value to look up information about them. Okay, we'll talk about how to do that using the hash map. All right, specifically we'll talk about hash map, but there's other maps as well. So if we think of the keys, right, of the map as being a set of values, like what you talked about above, a set, right? And then the values that they point to would be a different thing. Would be, it's not even like a list or anything. It'd just be the value that that key points to. And the reason why I say those key values, those keys in the hash map or in any kind of map, the keys are a set, is because we can't allow duplicates there. We're using it because we're saying this key value, this particular value, it could be email address, it could be a TJ Kimlik number, it could be your student ID number, it could be your name, it could be lots of different things. Right? And we take that key and we say, I want to look at the value associated with that key. That key is going to point to something. Right? And so because each key points to something specific, we can't have duplicates in the keys. All right. Okay. So those are our objectives. I've done spent a little bit more time on this slide than I normally do for the objectives, but it's because I want to get you kind of introduced to a lot of the terms that we're going to be using in this set of slides. Okay. All right. Okay. So this is kind of an example of how we might use this. If we have, we need to write a program that checks whether a person is in a roll call list. So imagine this is what's the word? It's a liste. Yoklama liste. So imagine it's like we're wanting to get the list of students, right, that are going to be in a course, so that when the exam comes, we can create a list of those students who are there to make sure that we know if the person is there or not. I can kind of use it like as a sign-in sheet kind of thing, right? Now, we just want to say we want to store the names or the ID numbers, or whatever, or student objects. We could create a student object and put it in there. And we just want to know whether a person is in that list or not. We don't need to know where they are. We don't need to know, are they the first person in the list? Do they have the name that comes first alphabetically? We don't need to know whether or not, what position they are. That doesn't matter. We simply want to ask the question of, is that person enrolled in the class or not? Well, we don't really need an array or an array list or a linked list to be able to do this, right? All we really need is we need something that simply tells us yes or no that person is in our set. And so a data structure we could use here much more efficiently would be the set. Okay. So we'll talk about this map being an efficient data structure if we wanted to also include other information, such as their gender, their age, their year, and so forth. Okay, but if all we want is their names or just some other identification value like a student ID number, we can just put that in the set if they're in the class, and then if they are, it returns true for contains, and if not, that returns false. And we don't need to have it ordered. And in fact, it would be a bad thing to have it in an ordered data structure, because what happens if they happen to be last in the list? Well, it's going to take a long time to go through all those values. You guys remember the discussion that we had last year about different search algorithms, right? About, what's it called? Binary search versus linear search, right? Okay, and so if we do a linear search, because remember, it's not a sorted, even if it's not if it's a sorted list, then we can use binary search. But if it's not a sorted list, then we'd have to go through each value to find the person, to find out if they're in there or not. We'd have to search the whole data, the whole list of names, all right? Whereas if we have a set where we don't care what the order is, suddenly it becomes a lot easier to be able to tell whether or not something is in the set or not. All right, so anyway, so that's there. All right. So again, we talk a little bit about this. We've seen this before, is where things inherit from. Okay. And here, what we're talking about in this lecture is the set over here. And then also, well, you know what? Map doesn't show up yet. We'll get there though. Okay. But the set, right? And then the tree set and the hash set. Right? And then a linked hash set as well. But these are going to be the things that we will talk about here, and then the maps in the second half of this set of lecture slides. Okay. This was also something that showed up in the last lecture set, so I won't show that. All right, now we don't have any new methods or constants or anything in the set interface, but one thing that it does kind of put in motion for us, one thing it adds to our collection, is that it doesn't allow duplicate items. So if I try to put something in the set that already exists, it won't add a second one of those. It will just it won't add it in there, right? And so I can't add more than one, right? And so it just simply says, does it it just simply makes sure that only one of each thing can be in there. Now, the main thing to remember is that this E1 dot equals E2 is true. Is like basically no two elements E1 and E2 can be in the set if those two things are true. Now, if the equals method is not overridden, so if you don't override it, so if you don't have a way to compare two items, two objects of the same type, whatever you're creating, then the equals method by default, what does it do? Do you remember what it does? Does anyone remember what the equals method does? Right, it returns false if they don't equal each other, true if they do, but what is the code inside, like from the, if you don't override it in some way, like we talked about with geometric shapes where we check their areas to make sure, to see if they were the same. Do you remember what the equals method in the object class does? If not, it's okay. It's just yes, yeah. So let me go ahead and write in here. I'm gonna go ahead and do this. Okay, so That's what it that's what the equals method on its own does, is it says, well, it returns that. It returns the result of that comparison. E1 double equals E2, which as Recep Samet says there, is he checks memory locations, because what it's actually asking for two objects is it's saying, does this point to the same thing that this does? So are they pointing to the same memory location? And if so, then they are the same and we return true. And if not, then we return false. Now, one of the things we talked about was for comparable items that we want to be able to compare one to another, and not just say, do they point to the same object, but are they effectively equivalent, right? We would override the equals method and we would have it return something like checking if the areas are the same for a geometric shape. I might compare if two students' ages are the same, or if their name is the same, or if all kinds of different possible things that we might check to see for students being the same, right? And so if we do that, if we override the equals method, then what will happen is we won't be allowed to put, for example, two students into the set if they have the same name. Okay, or if two geometric objects into the set if they have the same area, right? So we have to kind of be careful here, right, about what we do with equals. In fact, what we saw when we started talking about geometric objects was, rather than overriding the equals method, what we did was we wrote the compare to method. And so what happened was we were able to return a negative value if one was less than the other, a positive value if one was greater than the other, and a zero value if they were the same, right? So there's a difference between the equals method and the compare or the compare to method. Okay? We talked about those two, the compare and compare to, in the last lecture. So if you want a refresher on that, you should go watch that recording. Okay, so two items in the set cannot be there if they are, if the return value of the equals method is true for them. So if we don't override that method, then what we're really saying is the two elements cannot be in there if they point to the same object. Okay. All right. So I don't want to talk too much about all this different hierarchy stuff. I really just want to get to how we use it. Okay. Hash set is probably what, if you do something involving a set, it's probably going to be something you use most frequently. And one of the cool things about the hash set is we will look at it in, what's that thing called? The canvas, so that you can kind of see it visually, because again, I love seeing these data structures visually because of how it's interesting to see how Java does this stuff. Okay. All right. One cool thing about the whole for each loop, though, is the for each loop in a set is we go through each item in the set each time through the loop, getting some value from the set and putting it into our element variable there. Now, one thing here is, because a set is unordered, we don't know how we're going to get it, right? We don't know what's going to come first, what's going to come second, what's going to come third, and that can be helpful in some situations. So say, for example, I wanted to calculate the average grade on a quiz for this class. And what I might do is I might put, okay, wait, no, because a set, you can't have the same grade more than once. Trying to think of something I might want to calculate the average of. That we might have not duplicates in. I can't think of one for the average, but yeah. Well, let's say that I wanted to calculate the the minimum student number from a set of student numbers that are in this course. Okay, then there's no duplicates. All right, now what I could do is I could put all the students into an array or an array list and then just loop through it item by item and look for the minimum one. Right, or I could take the array list of the array and sort it and then just take off whatever, just take whatever the first value in the array or array list, the sorted array list comes back as. Right. But in a situation like this, what I might do, I might throw all the students into a set, all the student numbers into a set, and then go through each item and look for the minimum one. Right. That's one option. The main thing is that if we need to go through and we just need to visit every value in the set, but it doesn't matter the order that we get them in, right? Then we can do that using this for each loop. Okay. So again, we're not going to be able to use. We're not going to be able to use a for loop in a traditional way to be able to get each item in the set using an index value, because in the set it won't be given an index value. It won't be given an index value because it doesn't have a position. It could be, and actually, if we do it as a so this Rejep Summit, your question is great. What we'll do is I need to make a note of this. We're going to look at the test hash set code, okay? Because what we're going to see is the way that a hash set is done. If it's the same set of values, if it's the same values, then it actually the order kind of will come out the same every time. But and you'll see why. But you're right that each time through the set, it could be different if like one value changes, for example, if we change a string value. Because in the example in the test hash set code, it's using strings as what it puts into its set. Okay. All right. So I don't want to spend too much time on this because you haven't seen this code yet. So I'm going to go ahead but you'll see what happens with this whole for each loop. Okay. Linked hash set. There's a sorted sub interface set. All right. But basically, the main thing is the main thing about the set is, again, it's unordered, non-duplicate collection. All right. We talked about this last time about using the comparable interface versus a comparator interface. Right? So we can use the comparable or the comparator to be able to compare two items to each other. Right? So we can either, again, what I talked about towards the end. Arjun, I would say that would be difficult to do because since a set doesn't have an order to it, you wouldn't be able to mix things up. What you could do, is have something like you can have a set that is the deck of cards, and you could not sure how you would randomly get something out of it because you can't really randomly. But what you could do is you could check to see if like the set could be what is it, like a hand that somebody's dealt. So like if you're playing a card game with a friend, you know, or whatever, and you get a set of cards and it doesn't really matter what the order is. I don't know many card games where the order doesn't matter, but you know, it happens. And you get a set of cards and it could just check and see, is that card in his hand? Is that card in that set? Okay. I mean, I guess Go Fish. I don't know if any of you guys play Go Fish. I have kids, and so they play it, but I don't know if you've ever heard of it. I don't know if they have a similar card game for Turkish children, but that would be one where order doesn't really matter. All right. So again, so we could do the sorted set using a comparable or comparator. I talked a little bit about the difference between those last week. Okay. We'll also have a tree set. Again, all these different types of sets. As far as for the course like this, the different types of set, the tree set, the hash set, the sorted set, you're not going to use them very differently one from another, but as you learn more about your data structures and your algorithms courses later on in your university experience, you'll learn why each of these may be a little bit different and which ones might be better in certain situations. Okay. I want to get done with sets and lists. So we're going to look at this one for sure, how sets and lists perform, and I'm going to show you visually why they kind of work this way. Okay. And counting keywords is a good use of a set, and we'll show you that one. Okay. Like I said, I want to try to get through all the slides before the break time, which is only about 10 minutes away. So forgive me if this is a little bit much for a 1 hour lecture. Okay. All right. But the map interface is going to, if you've ever done any coding in Python, this is like a dictionary. This is a really good tool that Java gives us. And the idea is that instead of having an array where you have indexes 0, 1, 2, 3, 4, and so forth, and some value that array position points to, instead what we're going to have is we're going to have some type of search key, all right? And then that search key is going to have a value associated with it. So in this example, this could be like an ID number, like a TJ Kimlik number, or because this is a probably example based on an American style thing. This looks a lot like what's called the Social Security number in America. And we would we would assign the keys. So we would say, John's social or John's TJ Kimlik number is this. But when we look for his TJ Kimlik number, we're going to get his name. Okay, so when we access the key, we get the value. And this search key can be any object. It could be a string. It could be an integer, like capital I integer object. It could be a person, like a person in your what's it called? In your assignment, for example. It could be a course in your assignment. So we might say, look for a course. And over here, right, so we look for a course and we might say, tell me who's the teacher for that course. So you might have a course search key and a, what's it called? And a teacher value, a teacher object value. And then you can have a key, so CSE 102, and you get Joseph, right? There's all kinds of ways that you can do this. Okay, so a lot of good questions here. Can we create a nested hash map? So what you're asking is, can you have a key that then holds a hash map that it points to? And the answer is absolutely, absolutely. You can definitely do that. What you can do is you could have, just thinking off the top of my head, you might have the search key could be the semester. The value is a hash map of all the courses that a student has taken in that semester. And then for that hash map over here, the keys could be the courses and the values could be the grade. Right? So what you might say is search for semester spring 2021. Okay. In what you get when you search for that semester, you get a hash map, and in that hash map, search for CSE 102, and what you get is a double value. That's a grade. All right. Just thinking off the top of my head. Okay. Guess what? You could also do it the other way too, can't you? You could say search for a course, CSE 102. The value is a hash map where the key is the semester. So you said, so say CSE 102 gives me a hash map. In that hash map, I search for spring 2021. And what do I get? The grade. Okay, so you can do it either way. Okay. And you can do it as far down as you want, because the cool thing is that the search key can be any object. The corresponding value can be the object. A hash map is an object. So what I can do is a search key can point to an object. Oh, good question, Bearcat. Into that. Okay, what happens if second value with the same key? We'll see what happens with that. Okay, that's a good example we'll look at. All right. Omer, I kind of threw a way that you might use it in assignment 4. I talked through 2 different ways that you might use it in assignment 4. So I'm just laying it out there. Just put it. Okay. All right. Let's see. So this is just a visual understanding of how the map is the map hierarchy is done. Okay. And the whole concrete stuff. So you have a hash map, a linked hash map. Really, hash map is what you'll use more than anything else. I would say tree map. There's an example involving tree map, but it's one of those things that if you understand, when you guys get into your algorithms and data structures courses, it'll make more sense why the tree map might be more useful than a hash map. For this class, either one, you can flip a coin to decide which one you might want to use if you needed a map, because they both work the same. Okay. Okay. So the way one thing I want to, where is it? There it is. Okay. I want to talk. I forgot to go through this here. The way that the map works is you identify what's called a key value pair. Okay, so we have a key type. It can be any object. We have a value. Be any object. Okay, and what we can say, look, we have a few Boolean methods that are great that we can say, hey, does this contain a certain key? And if the answer is yes, then it returns true. If it does not contain that key, it returns false. So it's kind of like a set contains method. Okay, and if we think about it again, as I said before, the set of keys acts like a set, meaning we don't get to have duplicates. Okay. We have to see if it contains the value, but the difference between the contains value and contains key is that it returns true if the map has one or more keys to the specified value, because that same value can appear more than once. So again, think about that the value might be a double value, like the grade, right? A grade that somebody got in a class. That value might appear more than once. Same student might get the same grade in more than one class. You might get an 80 in 2 different classes, right? And so that value could appear more than once. This just checks, does it appear at least once? And if it does, then it returns true. If it doesn't, it returns false. The main ones I want to talk through, though, is this get, put, and the key set and entry set are okay, but really the key set, the get, and the put. So to put a value, to add a key value pair to the map, is we use the put method with the first value being the key and the second value being the value that key maps to. Okay, so this comes to your question, Berkai. So what happens if I put the same key that already exists with a different value? Okay. This operates like the array when we go think about the last year. I know this is a long time ago, okay? But you guys are much younger than me. You should be able to remember that far back. Okay, but if we took an array and we said, array at index 0 equals something, what happens? Do you remember? Right, it changes it. It replaces the old value with the new, and the old value goes away, doesn't it? It just disappears, right? So like if I did this, if I had an array called, let's say an array called array. An integer array, let's call it an integer array. Where are you? Okay, so let's say I do this. Right, so let's say I do that. Now the first line sets that array at index 0 to be the value. Then that second line changes that value to 24 instead. And 3 goes away, right? We lose 3. 3 is no longer there. Right? And that's what would happen with the put. Okay, so if we put something with a key and a value in there and the key doesn't exist, it adds it to the. If we put something with a key that already exists with a new value, it replaces the existing one. Okay, and the old one disappears. Okay. Get is simply like the array list get. We get, well, array list get, but where the array list used an integer index value, this just says if that key, give me the value that's associated with that key. And then key set and entry set. So basically, the key set, it returns a set that represents all the keys that are in my map. Okay. And then the entry set returns a set of map. Okay. This one's not used so much. This one can be helpful if we want to just get a set of all key values that are in there just to see what's there. Okay, so you might want to say, if you wanted to have a set of values for use in some way. We can remove a key. We can get rid of a key that gets rid of that value. That would get rid of all. So if the value were another hash set or another collection of some kind, that would go. All right. So that's how you use the map. So your main things I want you to get out of this is the put method, the get method, and the two contains methods. Those are the ones you're going to use more than anything else if you use a map for some reason. Okay. And the hash map and tree map, there's a little bit of difference between how they work in the linked hash map. And we are just out of time. So we will look at this example too when we come back. So I think that's all of it. Yep. Okay, so that's all the slides. So I know that was a lot, and I really think that using the using the code and using these different data structures, the sets and the maps in code examples is probably going to help you more than anything else. So when we come back from break at 2:32, then we will go through some examples. Okay. All right. So I'll see you in 10 minutes. And all right.